So, good evening to all the fellow developers who have joined us today in the 2022 Solution Challenge opening workshop. So, let's get started with today's event. So, before I introduce you to about Solution Challenge, let me introduce you to our fellow developers who are with us as the speakers of today's event. Apurva and Harsh, both are part of Team Kotlin, which is a specific domain related to Android development. If you have been following us, you must be knowing that we have conducted Android study jams in which we taught about Kotlin and Jetpack and all the things related to recycler views and core Kotlin. So before moving to the coding part and getting interested in the Kotlin domain and Jetpack Compose, let me tell you about 2022 Solution Challenge. You must be thinking that what it is and why should we participate in that. So the mission of 2022 Solution Challenge is to solve one or more United States problem using Google technology. Now, you must be thinking that exactly what is it is. So Solution Challenge is a hackathon started by Google around 6 years back to open to all the Google Developer Student Clubs. Now, if you are a member of Google Developer Student Club, VIT Bhopal, you are free to participate in it and learn a lot of things using Google technology. Our developers, our speakers, and our mentors would always be there to you for guiding you. Either it's Instagram, Discord, you can contact us anywhere and we would be ready to help you. So moving forward, that why should you participate? So let me tell you about the prizes. The top 50 teams will win a T-shirt, certificate, and mentorship from Googlers and other experts to improve and submit a solution for the top prize. Now, what if you get into the top 10? You will win a $1,000 cash prize per team member. You will get exclusive Google swags, certificate, and mentorship from Google, and feature in the Google Developers blog and a demo day live stream. It's a very big thing. Now, what if you win Solution Challenge and you are in the top three winners? You will win a $3,000 cash prize each team member, exclusive Google swags, certificate, mentorship from Google, and you will feature in Google Developers blog and a demo day live stream. Now, you must be thinking that what are these 17 United States Sustainable Development Goals? These are very general goals that we usually see even in India in our day-to-day lives. That is no poverty, no hunger, good health, quality education. You must be seeing that these things are promoted by government as well as private organizations to maintain a particular democracy and particular maintenance of nature in India. So for that, I would like to forward to Apurva and Harsh to make you go into the code part and learn Android development using Jetpack Compose and Kotlin. Thank you.
Hello everyone. So we'll be making a simple pedometer app. Pedometer is basically an app that measures the steps of a person. So I'll show you how to create a new project. So for creating a new project, you will click on new project over here. And since we are making it with Jetpack Compose, so you'll click on empty compose activity and then you'll click next. Over here, like we are making pedometer, so let's just name the app as step counter. Step counter. So you can see that the package name automatically got edited up and the location is also changed. We are keeping the minimum SDK to API 21, which is required for imposing Jetpack Compose. When I click finish, there will be a new project created and the Gradle build will work. Since I've already done that, so I will show you is the project. I'll share my screen again. Give me a second. And you can see the project. So it will work. It will look like this, a very simple project. Now, since we are making a pedometer, we need some permissions. So we'll add a permission by going to the manifest part from over here. I clicked on Android manifest and I reached here. Now we need permission. So I'll say users permission for activity recognition. Since it's a sensor app, so it will require activity recognition. I'll close the bracket. Now we'll go back to the main activity part. Now in main activity part, I'll remove the part that was not needed by us for now. And this part. So this part is where the display will show up, the UI of the app. So that will be shown by Harsh. I'll start with the coding part. You can see all the imports. It will get more imports as we code on. So I'll start by adding sensor event listener. Now, what is sensor event listener? Sensor event listener receives notifications from sensor manager when a new event is there. So we'll have to create some values and variables. We'll initialize values and variables. So I'll say private variable, and let's say first I'll create sensor manager. Sensor manager lets us use the device's sensors. So I'll say sensor manager, and then I'll write sensor manager from here. And since we are initializing it, we'll say null. We'll create some more variables, like for activity part, we'll create private variable running. We'll initialize it as false. One more private variable, and we'll say this is total steps. Now total steps for now will be 0f. F here is the float value. Another private variable will be created that will be later done by Harsh. Now I'll create a private val. Values are immutable while variables are mutable. So I'll create a private val activity recognition request code. We'll see later how it is used. Now I'm using private variables, so they can be used in only in the same scope. They cannot be used outside of the loop. So we'll come here and I'll add @requires API. Requires API. So requires API denotes that the annotated element can only be used on a particular given API level or higher than that. So I'll set the API level by writing build dot version code dot q. Now the q part here is a API code for an API level. So the q will be for API level 29. For every API level, there is a particular API code, which you can find in version #SDK. I'll import this part. It automatically gets imported on its own, but sometimes you have to do it. So we'll let this part remain as it is. We don't need to change over here. Here will be the display part, like I said. And we'll start with the coding part. So for first, we'll just check if the permission is granted or not. So I'll just write a comment to make it easier to understand. We'll say check if permission isn't granted already. We request permission. So we'll say request the permission. Permission is for the sensor part. So now I'll make a statement if I'll say if is permission granted. It will come as a warning for now since we have not created this function yet, but once we create the function, the warning will disappear. Now I'll say request the permission. So I'll say request permission. Now since request permission, so it will go to the sensor manager as we are using the sensor. So sensor manager will get system service. In that also we'll get sensor service. So we'll say context and write sensor service. Now as sensor manager. Now we'll move on to the functioning part. So the fundamental lifetime of an activity is between two functions, on resume and on pause. So in this period, the activity is invisible, active, and interacts with the user. So we'll first start with the on resume part. I'll say override function on resume. Now I'll come here and we'll start with the coding. So override function on resume, and I'll write running equals to true. Why running equals to true? Because the user is interacting with the activity, so the activity will be going on. In the above case, it was false since we were just initializing it. So now we'll set the sensor. We'll go to val step sensor, and then we'll write equals to sensor manager since it is managing it, and we'll get the sensor that we want. So we'll say get default sensor since it is a step sensor, so it will get sensor dot type step counter. Now type step counter is basically a constant that denotes the step counter sensor. So it will get the number of steps taken by a user. So this sensor requires a particular permission which we gave in the Android manifest. So if you remember it, please write it in the chat box. Let's see if you paid attention. And till then, we'll make an if and else condition. So like if the sensor is available on our device or it is not. So we'll say if step sensor equals null. It means the sensor is not available on our device. So we'll create a function for it, and we'll say we'll make a toast. Toast is basically a pop-up notification for a particular function. So toast in context with this, we'll create a text. It will say no sensors detected on this device. Now, how long do we want this toast to appear on our screen? We'll say toast dot length short. So it will show for a little while, and then we'll say show. This is the if condition. Now what if the sensor is available on our device? So else condition will be, we'll open the curly braces, and if it is available, then it will register the listener. So our sensor manager will be registering the listener. So registering the listener, so we'll write in context to this step sensor, and we'll write sensor manager dot sensor delay UI. Now this was the on resume part. In the on pause part, what happens is the user does not interact with the activity, but it is still visible. So we'll do the on pause part. We'll write override function on pause. Now come here. In this case, the activity will be false. It will be running equal to false. Now we'll just unregister the listener. So we'll say sensor manager or unregister listener. This is the on pause part. We'll create some more overriding functions in method. So we'll say override function. This will be on sensor changed. Now on sensor changed is used when the value of the sensor is different, news. So, but also the point to be noted is that it does not mean the sensor has to change. If we are getting a new value, even though the sensor has the same value type, but different timestamp, then also we will use this part. So we'll remove this line, and over here we'll write event in small. And over here we'll write if activity that is running. So I'll write a comment so that what we are going to do. If activity is running, we'll get the number of steps taken by the user. Yes. So now we'll get the total steps equal to event dot values initialized to 0. Now here another statement will come that will be later done by Harsh, and that will be all for this function. Now one last overriding will be override one on accuracy changed. In this, the accuracy of the registered sensor changes. So we'll write over here sensor, and over here we'll write accuracy. Accuracy means low accuracy, medium accuracy, high accuracy, that. So over here we'll just write a line, print ln, and we'll say on accuracy changed, we say sensor, and sensor will get the new sensor, so it will be sensor. And same will we go for the accuracy part. Accuracy will be the new accuracy. These were all the overriding function part. Now we'll create a private function. You can see there were two errors above. Request permission is permission granted. These errors will disappear now once we make a private function. So we'll start with private function of we'll say request permission first. So we'll make parentheses and then curly braces. Now we'll start. So since it is a request permission, and since we said that it is a request API, requires API one, so it has to be greater than or equal to the API that we mentioned, that is level 29. So we'll write over here if build dot version dot sdkint is greater than equal to the one that we defined, build dot version codes dot q. If the API level is equal to 29 or greater than 29. So then we'll make parenthesis. Then activity compat. Activity compat is basically it allows us to use the features of activity. So activity compat dot request permissions. So and in this we'll write in context to this, and then we'll go to the part where we gave the permission. So we'll go to array of where we gave the permission was the manifest part. So we'll say manifest dot permission dot, since it is not imported, so first we need to import. Okay. Manifest dot permission dot activity recognition. All right. Now we'll say activity recognition code that we said. Okay, I've been using this a lot. So this is basically meaning instance of the class at that current time. So if we are using it in activity, that means instance of the activity. Activity is basically a subclass of your context. So when we use it in context, it means context of the activity. So we're done with this part, and now we'll make another private function. The one that is left is permission granted one, as you can see. So one error is left. We'll create another function. We'll go to the @requires API, and we'll write the version that we were doing, build dot version codes dot q. Now we'll say private function, and we'll write is permission granted, and we'll get it. We wanted to give a boolean value, so we'll say boolean, and it return context compat. So context compat is again like a feature that allows us to use the it allows us to use the features of context basically. So context compat, and context compat will check for self permission. Check self permission checks if the user has granted a particular permission or not. So we'll check self permission. Okay. Yeah, this is not needed. Yeah, we'll say this, and then we'll go to the manifest part. Manifest dot permission dot activity recognition, and you're seeing that it is showing an error. But once it checks with the package manager, the error will disappear. So we'll write package manager where it will show if the permission is granted or not. So package manager, and it will say permission granted. See, the error has gone. And the above case also, you can see it is no longer in red. So this part is done, permission granted, and now we'll do the last part. Last part would be, I'll write in comment, it means handle requested permission, like if it is allowed or denied. So we'll say handle requested permission result. Basically allowed or denied. So we'll code this part. We'll say override function on request self permission, on request permission result. So we'll say on request permission result. You can see it is deprecated. So it's not a big issue. I mean, you can have alternative as well, like you can use register for activity result, but it won't cause any problem right now also. So we'll say when will this happen? It will happen at request code. So we'll code it. So I'll open the pieces and then we'll go to activity recognition request code. And we'll establish the statements. Okay. So we'll say if grant results is not empty, means it has a value allowed or denied, and grant result we need to initialize to 0 is equals package manager permission granted. So once it is granted, if it is granted, then we will do the workflow or functioning of the app will take place. If it is not granted, then it won't take place. So I'll just write a comment over here. Comment will have, let's say, we'll say permission is granted. Continue the workflow in your app. So this was basically the functioning part. Now only the UI part will be done. So UI part will be done by Harsh. Now he will take over from here. Okay. Harsh, you're not audible.
Yeah,
Yes.
I guess now I'm visible and audible. Right.
Yes.
So till now we have only worked with the Kotlin, and by using the Kotlin, we have fetched the total step that we have covered, and this value is currently in float. So basically, the sensor manager provides the current step data in float format. So now we have to render UI by using Jetpack Compose. So Jetpack Compose is basically modern UI toolkit that is provided by Google, and you can create beautiful UI but by just using Kotlin, simple Kotlin function. So let's say I'm creating a function named display. So this is a normal Kotlin function, and to convert it into a composable function, we have to use composable annotation customer kit. So basically, this is an empty function and this is not rendering anything in the UI. So we wanted to render the current step that is covered by the user. So for that, we have to create a mutable variable just at the top. So I'm creating private current state mutable state of total step. So basically, the current step and total steps, both the values are same. there's a minor difference, that is this variable will re-render the UI whenever it gets changed. So we don't want our UI to be, static. It should must change whenever the total step is changed. So I'm converting it into integer because we don't want the step in float format. So yeah, our mutable variable is ready. So I have to also change it when the total step is changed. It means whenever the sensor change, we are storing the event in the total step, and just after that we want current step to be changed. Take the value of the total step and by converting it into integer. So now we are done with the current step, and now we will use a text widget to show this current step. By using a dollar, you can add variables in a string. So let's uh, let's use one more feature that is provided by Jetpack, that is preview. It means you don't need any physical device or emulator to see the UI of any composable function. So the preview will show the UI that is going to be rendered by this composable function. I can set the show background to true, which will add a white color background behind the UI. So let's build and refresh. Yeah, it's showing U0 because we are using a virtual emulator kind of thing. So in this, the sensor manager don't work because you need a physical device for this. So this is a very basic UI. It will, when you render this in your phone, it will go at the top left corner. But we are planning to achieve something like this. There should be current step, the goal, and user can input and change their goal. And these two arcs that is in the background, the first one that is in gray color and the other that is exactly at the top of the previous, that is in red color. So to create this UI, we will require layout, that is box layout. So box layout does uh, any element that we put inside the box, it will stack over each other. So that's what exactly we want. So we are using box. Yeah, and inside this box, I'm adding this text. Yeah, this is a simple text, and I want to draw this arc. So whenever you want to draw something in the UI, you have to use canvas. And in canvas, you have to add the modifiers. Modifiers are nothing but you can modify any widget. The name itself suggests it's a modifier, and modifier can change anything of that widget. Let's say I'm changing the size, that is 300 dp. The size of the canvas is 300 dp, and we also want our canvas to be fit in the box. So the size of the box should be same as the canvas. So again, I'm using modifier and 300 dp. And one more thing that I have failed, all these are stacked over each other and they are sharing one common center. These three elements are concentric. So we have to add content alignment, alignment dot center. It will align all those elements in one center. So I've added canvas, I've added text. So it's time to draw the arc. So I'm using draw arc function, and it requires some mandatory parameters like start angle, from where your arc should start, sweep angle, the angle of the arc. I want a complete 360-degree arc, so I'm using 360. I'm using F after all these values because these values are in float. Okay. So the color of this arc, colors dot gray. Previous arc is the art that is in the background is in gray color. So the style of this arc, I want only a stroke, and the size of the stroke is 40. And one last thing, use center. I don't want to use center. So I've created one arc, and now let's re-render the UI and see in the preview that what actually happening with this. So you can see that we have got this gray arc, and now we need a red arc just above it. So I'm selecting the previous arc and pressing Ctrl D. It will create one exact copy of that code. And this time I want red color. You can change your color according to you. And if you will notice that the edges of the above arc is kind of round. So I will use the cap, so cap dot round. So now again re-render. We are again creating a 360-degree circle above it. So we don't want this. We want this to be more dynamic. So let's check, is it working or not? I want a 19-degree arc. Let's see if it creates or not. So it's creating from the rightmost corner, but we wanted our uh, the another arc from the top. So for that we have to just change the start angle. If this is 0, so definitely this is minus 90. So I'm using minus 90, and now I want this to change according to the current goal and the current step that is covered. So we have not defined anything for the goal. So it's create a var goal mutable state of, let's say, 200, the initial value. But there is some error. Whenever we create a variable inside a composable function, so whenever it will recompose, as I already told that composable functions get re-rendered whenever a value gets changed. So whenever this function will recall, so this goal variable will be reassigned, but we don't want it. We want to remember it. So we will tell the function to remember it and put this mutable state inside it. So even after the decomposition, this goal will be remembered. So now we will use this goal and current step to cover the exact portion of the UI. Right? We will divide the total goal by the current step by total goal, and it will give the correct proportion. Right? So again, pre-render. So yeah, the current step is 0, so the portion must be 0 now. So when you run this in the physical device, it will start increasing while you run. Okay. Now the text. If you see in the goal UI, we have used some different kind of text. That is, the first part is in the bigger size, and the other part is kind of smaller. So basically, I have used two text widgets. The first and the second, both are in a row. So let's create a row and put both the text widget inside it. This is the first, and I'm adding the style. Whenever you want to style any text, you have to use text style. And when you hover here, you can see in the banner that there are so much things that you can do with this text. So I'm going with simple font size and 16.sp. SP is not the default unit for font size. And I want one more text field, the second one. And in this, I have to add a slash and the goal. and the size should be 30. And I have to add modifier here because this is, there's a padding just above it. So I'm adding modifier dot padding at the top. Now let's re-render. So we have created this box layout in which all these elements are at the correct position and all are working fine, right? So now there is one more thing, that is the text input field. So these all this box field and the text input field is in a one column. So again, I'm creating a column, putting this box inside the column. And I'm adding an outline text box. So it requires some mandatory parameters, value and on value change. So for value, we have to create one more mutable variable. So I'm giving it the name of text value. And the initial value is int string. So the value is text value and on change. So whenever you change the data here, it should must change the text value. So I will change text value is equal to it. It is it means the content that is currently in the text box. So whenever you will change the value, it will get assigned in the text value. But we don't want to change the text value. We have to change this goal because we are setting goal via this text field. Right, so we have to do something else here. I am adding one more thing, that is goal is equal to text value, and text value is in string. So let's convert it into integer. So what we are doing here, we are taking the text from the text box and setting it in the text value. And again, I'm converting that text value into integer and setting it into the goal. So our goal will also change whenever you will enter something. And then now I'm adding label. Label is text, set your goal. Now let's re-render and see what's going on here. So you can modify all these things according to you. If you want, you don't. If you wish, you cannot use this column structure. You can make it kind of different. It means you can click and you will get pop-up of set your goals. But I have made this simple. As you can see, there is no space in between this box and the input. So I have to add padding. Again, to add padding, I have to use modifier. Modifier at padding.all, and let's say 60.e. Now we are complete with the UI. One last thing that we have to do is to align the content of this column. Okay, because these are horizontally centered, right? So I'm using horizontal alignment is equal to alignment dot center horizontally. So we are done with our UI, and now we render. Yep, and you can see that all the field that we are required for this goal UI is achieved. And let's run it in our emulator and show you the exact. So if you change your goal, it's a 500, it's changing. So in the emulator, we cannot change the current step because there is no sensor in the emulator. But when you use in physical device, it will get changed. And I hope that by this session you have learned something, and uh, you can check out our GitHub link where we have pushed all this code. And if you have stuck in between, you can refer to that code also.
So that will be all on the making the pedometer part. If you have any questions, feel free to ask in the comment section. The last date to submit the project is March 31st. Okay, if you have any question, then we'll be closing the session. Okay, that will be all from our side. If you have any question, feel free to reach out. Thank you.
Have a good time. Bye.